Lesson 3 of Chapter 2 is on the remainder and factor theorems. Before we get to those two theorems, we need to talk about dividing polynomials. In Algebra 2, you learned how to divide polynomials. And again, a polynomial is a function that has non-negative integer exponents. And so we're going to be taking two different polynomials and dividing them. Before we do that, let's just review how we divide just numeric values, numbers, because the process is done pretty much the same. If we're going to take 637 and divide by 20, we set it up this way. We got 637 that acts as the dividend and 20 acts as the divisor. So you'd start off by saying how many times does 20 go into 6? That answer is obviously none. So then you'd add another digit and you'd say how many times does 20 go into 63? Well, that is 3, so we put a 3 up on the top. Then we take the 3 on the top, multiply it by the divisor, 20, write it underneath, and then we would draw a line and subtract the 60 from the 63. Well, that would give us 3, and then you'd bring down the next digit of 7, and you'd do the same process again. You'd say how many times does the divisor 20 go into 37, and that's once. Put the 1 up on top, take 1 times the divisor, write it underneath, subtract, and we get 17. Now, what we're going to be doing with polynomials is we're going to take our remainder, in this case 17, and we're going to put the remainder over the divisor. So here our answer is 31 and 17 over 20. We're going to do that same process now with polynomials. So if you read example 1, it says factor this polynomial completely. Well, this is a third degree polynomial, which means it's got 3 factors. So our answer is going to end up looking like this. Three groupings, 3 sets of parentheses. And it says factor this completely using long division if x minus 3 is a factor. So I know one of our 3 factors is x minus 3. We got to find the other 2. To do that, we're going to use long division. So I'm going to divide this third degree polynomial by x minus 3 to find the other 2 factors. Now, because x minus 3 is a factor, I should get 0 for my remainder. It should divide out evenly. So I'd start out by saying how many times, what do I have to multiply x by to get 6x to the third? And that's 6x squared. If I put that up on the top, multiply that by the divisor, I get 6x to the third minus 18x squared. Now I have to subtract. And when I subtract, you can see that the 6x to the thirds cancel out. We end up getting negative 25, and then this becomes plus 18, so we get a negative 7x squared for a result when we subtract. Bring down the next term, do it again. What times x gives us negative 7x to the second? That answer would be negative 7x. We multiply the negative 7x by the divisor. That gives us negative 7x squared plus 21x. Now we're going to subtract. When we subtract, you can see that these first terms cancel out. Ends up giving us 18x minus 21x, which is a negative 3x. Bring down the 9. Do it one last time. What times x gives us negative 3x? That would be a negative 3. Multiply that by the divisor. Subtract. We get 0 for a remainder. And on this problem, we knew we should get 0 for a remainder because we knew that x minus 3 was a factor. And so now I have to take the quotient, the 6x squared minus 7x minus 3, and I have to finish factoring that. So let's take the 6, send it to the back, factor this into negative 9 and positive 2. But then since I sent the 6 to the back, I have to divide both of these by 6. That would simplify down. The 9 over 6 simplifies into 3 over 2. So this factor is 2x minus 3. And then this factor, the 2 over 6, reduces into 1 over 3, so this becomes 3x plus 1. And those are my remaining 2 factors for my final solution. 2x minus 3 and a 3x plus 1. So that is the complete factorization of that third degree polynomial. Let's do another example of the same kind of problem. It says, again, factor each polynomial completely using the given factor and long division. So I'm going to take the third degree polynomial. I'm going to divide by x plus 6. Should get a 0 for a remainder, which means it divides out evenly. If it doesn't, I made a mistake in my long division. How many times is x going to x to the third? Multiply that by the divisor. Subtract, it will give us 1x squared. Bring down the next term. Do this again. What times x gives us x squared? Multiply that by the divisor. Subtract these terms from the term above it. It gives us a negative 2x. Bring down the negative 12. Do this one last time. What times x gives us negative 2x? Multiply that by the divisor. Subtract. We get 0 for a remainder. So our final answer, again, has to have 3 groupings. And one of the groupings is x plus 6, because they told us that x plus 6 was a factor. And then I have to just take my quotient and factor that, and you can see this would factor into x plus 2, x minus 1. And so that is my final result for my 3 factors. So again, here we're using long division to completely factor a third degree polynomial. Well, the next example is different. It just wants us to divide these 2 polynomials. It doesn't necessarily mean that 3x plus 2 is a factor of the third degree polynomial, which means it doesn't mean we're necessarily going to get a 0 at the end for a remainder when we divide. So when I set this up, one of the things I want you to notice is that my dividend is missing an x squared term. So since it's missing an x squared term, you're going to see I put in a 0x squared, then I got a minus 1x, and then a minus 3. So now as I proceed to use long division, again, I won't necessarily get a 0 at the end. 3x squared on the top, multiply that by the divisor. That gives us 9x to the third plus 6x squared. When I subtract, we get a negative 6x squared. Bring down the next term, do this again. What times 3x would give us negative 6x squared? That would be negative 2x. Multiply that by the divisor. Write it underneath. That gives us a 3x when we subtract. Bring down the negative 3, do this again. What times 3x gives us 3x? That's just a 1. Multiply that by the divisor. And as we subtract, it gives us a negative 5. So you take your remainder and you're going to put that over the divisor. And so this is the answer you get from long division on those 2 polynomials. Let's just do one last example of dividing 2 polynomials. You can see my last one here. This time we are dividing by a second degree trinomial. Okay? Well, it gets done the same way. But since my divisor has 3 terms, instead of writing 2 terms underneath each time, I'm going to be writing 3 terms underneath each time. Doesn't look like I have any missing terms. So if I put them in descending order, which they already are, I should get my result in just a few steps. So what times x squared gives you 2x to the 4th? That would be 2x squared. Multiply that by the divisor, write it underneath. When I subtract, it looks like the first 2 terms cancel. I cancel my 2x to the 4th, so I cancel my negative 4x to the thirds, and it's going to end up giving me negative 1x squared. Bring down the next 2 terms, and then what times x squared gives us negative 1x squared? That would be just be a minus 1. That gives me negative 1x squared plus 2x minus 7. And now when I subtract, we'll end up getting a 1x minus 4. That's going to serve as our remainder. So I'm going to take our remainder, 1x minus 4, put it over our divisor. is your result of dividing those two polynomials. Hopefully those examples have helped you remember how to divide polynomials. Please remember to try to subtract your terms below from the terms above, and that's the area where most people make their mistakes.